Take one. This is the testing of the MC8051 core file using the hello.bin provided. So we are programming the basis 2 board and connecting via RS-232 using the switches.
And then we're going to
we're setting the hello.bin file.
The lights are on.
Lights are on.
And then create switch 0 to 1 button C, send file. LEDs.
As you can see, we connected the RS-232 to the JD and not JA, as that was not working.
Okay, and then we're going to enable this by pressing that.
And we got the zeros to output.
And then we switch. Just press button C, and there you can see we have hello in
Hello world in
hexadecimal.
Hexadecimal.
And then we're going to put switch 2 up again and dump the rest of the program code, which is very long. But up here, this is the instructions that were being sent in order to get the hello output.
This is an assembly code. It's the assembly code for the... It's 1:17 and we're trying to get our first Trojan to work. So take one.
It's dark. I hit no and now it doesn't know what to do with it.
It has already effed up.
Cancel the video.
No, keep going, keep going. Screw it. The hell.
Let's see, I'm gonna open my bits.
Yeah, it's Trojan one, yeah.
Program.
Alright, so it's working. All
switches are down, so now we're gonna go over here. We're already connected. Switch up.
Wait,
that.
something's wrong. Usually the lights turn on.
Well, we have to send the file. You hit that to send the file. Now we send the file.
Yeah, there you go. The lights are on, sorry.
Now we put this down.
We're getting all zeros.
That's the initial dump.
Initial dump. Hit the switch.
Enable that. And
Switch
then
went on.
And this right here is where we have the assembly code again.
That's our assembly code, and our output is
here. Only these last three characters are displayed because the Trojan is designed to ignore any files that are located inside registers 30 through 37. Therefore, instead of modifying the
hello world.binary file, we
modified the Trojan to work with it.
Yes, because we had a hard time getting the Python code and the text to bind work, so we just did that, and pretty much it's working. And that is it for Trojan number 1. This is Trojan 2. It's 3 o'clock in the morning, and we kind of got it to work. What we did was we attacked the UART by triggering a certain sequence, and when the sequence is triggered, the UART starts transmitting only zeros. And so this is what we have. We're programming the board right now. We just sent the hello world file. It's kind of glitching the output, but it's not quite what we wanted. What we wanted was all zeros, but for some reason it's giving us a pattern of DB, FB, F6, BF, and then it just keeps on repeating. But that's pretty much it. We tried to do using the RS-232, and that's it. So, bye. Basically just finished my third Trojan just now, finally, and we are going to test the third Trojan onto the FPGA. Pretty much what my third Trojan does is it has a counter embedded within the transmission line of the UART of the RS-232, and pretty much it has a counter which counts up for every bit that is being transmitted. I have set my counter to be triggered at the 8th bit, so once the 8th bit is triggered, it will then begin to transmit all zeros continuously. So let's give it a try. First, let's initialize the chain, browse, and let's find the .bit file. Open. Yes, program. So as you can see, we have was just blinking, so we just got the FPGA to implement correctly. So let's hide this. So as you can see, we already got all zeros, which means that the FPGA is working correctly, the transmission. So we are going to begin by sending the hello world.bin file. So here we go, hello.bin. But before we do that, we need to flick the switch up. Oops, wrong switch. Flick the switch up, press button 0, and then send the transmission. So we got the lights to turn on, which means that transmission is there. So we are going to flick the switch down and give it a try. So let's see what we get. So as you can see, it's beginning to transmit. But for some reason, oh snap, I forgot to. 1 second, let's give it another try. Forgot to click the button. So, send file. Make sure the switch is up, buttons on. Hello.bin. Open. Alright, so we got that. So we need to lower this, press the switch button. Button O. So you can see we got our zeros. Then to test, we would have to bring this up. And let's see. Oops. Alright, I'm sorry for the delay. I was just looking for the beginning of the transmission. So this is all zeros, and then as you can see right here, we just get a 75 in ASCII right there, and that triggers our 8th bit, and so then it just begins to transmit all zeros all the way down. And for any transmission after, it will keep continuing to transmit just all zeros, since once it is triggered, it stays triggered. As you can see, it's just going to keep transmitting zeros. And that is it for the third Trojan. There's a little bit of room to be worked on, but pretty much it's working just fine.